Well, hello, everybody. Thank you for coming to KBE Insider. And it seems like my camera has a little bit of a shake to it today. But I'm Langdon White, and I am formerly from Red Hat, and I am currently now a faculty member at Boston University in the Computing and Data Sciences faculty, where I teach data science stuff and I teach computing stuff, practicum and various other things. We also have Josh Berkus, who is co-hosting with me today. And are you there, Josh?
Howdy.
Seems we have no video.
Is video working?
It tells me it's working, but I don't think we're turned on, I think. But we can, do you want to just keep running? And we'll figure out how to get our pretty faces on the screen in a minute.
Yeah, we're getting audio. Anyway, I'm Josh Berkus. I work for Red Hat's open source practice office. And I am the Kubernetes person in our open source practice office, making sure that Red Hat is doing a good job in contributing to Kubernetes and many related projects. And as such, I've actually talked to our guest today, Liz Rice, many times in the CNCF.
Awesome. Thanks, Josh. So, we'd like to welcome Liz Rice, who is got a whole host of titles. But maybe you could introduce yourself with a little bit of the teaser, and hopefully we'll get video soon. Kind of, otherwise it's going to turn into a podcast or what's Twitter's new thing? Spaces? Is that what it's called? I listened to one the other day. It was actually pretty good on developer evangelism, or we don't call it that anymore. We call it developer advocacy. That's it. So Liz, tell us a little about yourself.
Hi, yeah, thanks for having me. I don't know what's happening without the video, but I guess we'll work around it. I'll pretend that it's a podcast. Yes. So I'm speaking from North London, where I've been working at home for the last, I can't remember how many years. I'm now the Chief Open Source Officer with Isovalent, who are the company that originally created the Cilium project. And I am currently the chair of the Technical Oversight Committee for the CNCF, the Cloud Native Computing Foundation. So, hi.
Awesome. That's really cool. Why don't we kind of start maybe with tell us a little bit about the Cilium project, I think, and maybe with a little bit of background in eBPF, because I think that's something that not a lot of people will have experience with, especially given that you have to have a very recent kernel, relatively speaking, to get eBPF. Would that make a good place to start?
Yeah, sure. So I think actually it's a very timely question, because I've been interested in eBPF for, I think I first saw Thomas Graf presenting on it at 2017, 2018. And I thought, well, that's really cool, but clearly it needs a new kernel and none of us have those yet. And,
Right.
This is going to take a while. And fast forward to, 2022 now, apparently. If I can remember to write 2022 and not 2021.
Right.
And the kernel support for eBPF has become much, much more widespread. The kernels that almost everyone is using in production these days now support enough eBPF functionality that we can do useful things with it, and like running Cilium and other eBPF projects. So that's probably a really, really core reason why over the last, let's say, 6 months or so, maybe a year, you'll have seen eBPF just kind of explode in popularity. It's because we can basically all use it.
Yeah. Right. Just for a little bit of background. So eBPF is kind of like a sandboxing tech for various functionality in the kernel. And why do people care? Well, because that way you can kind of host, quote unquote, dangerous things, right? Without having to worry about, giving them kernel access, except not giving them kernel access. And so I think Cilium, though, is specifically in the kind of the networking space, right?
Yeah. I'll expand a little bit about eBPF as a technology. So what it lets you do is run custom programs in the kernel, within the kernel. So the sandboxing aspect ensures that those programs are safe to run. For example, that if you're going to access memory, it's memory that belongs to the process that's currently sort of involved, or that you can't crash. You have to check that pointers aren't null before you dereference them, because it would be a really dangerous thing to, if you crash the kernel, your machine is gone, it's died. So eBPF sandboxing, or the verification process, makes sure that these programs are safe to run, but you can actually use it to customize the way the kernel behaves, with restrictions on what you can and can't do with that. It's pretty complicated, but you can actually hook into, for example, any entry or exit point to any function in the kernel or in user space. You can hook into any trace point. And for Cilium particularly, you can hook into various points in the networking stack. So Cilium it's best known as being a Kubernetes CNI, a Kubernetes networking plugin. You can use it outside of the Kubernetes context as well. But what it allows us to do is create networking endpoints for Kubernetes pods and connect them together in a really, really efficient way. People quite often talk about how we can bypass IP tables. We can bypass a whole load of unnecessary networking functionality, essentially, in the kernel by kind of hooking directly from pod to networking interface, or from pod to pod.
Gotcha. Yeah, that's pretty cool. I mean, I think one of the things that I was really interested to learn, I guess, I don't know, I was really surprised to learn a year or two ago, is like how root has kind of been broken apart actually into like a bunch of different functions. And so that's it's kind of in the same vein, it's like, it's not just a superpower user kind of anymore. And, and so you can now actually isolate, various processes from each other. And that has a lot of ramifications for, things like Kubernetes, and other, even virtual machines or whatever. It allows you to kind of give certain kinds of access, but not carte blanche, to processes that you may or may not trust, or kind of, at least in my experience, right, I've written enough bugs in my life that, I don't even trust my own stuff, right? I like to be able to isolate it from each other. So yeah, that's pretty cool. I think that that tech is getting really interesting.
I'll say in one of my roles, I'm actually one of the reviewers for submissions to KubeCon, and KubeCon Europe is coming up. And I'll say we certainly have quite a few talk submitters who think eBPF is what we should all be paying attention to. A lot of submissions with core, sort of either eBPF or I did this thing with eBPF.
Great.
Ideas behind them. The ones that are I did this thing with eBPF tend to get rated higher, since I think at least within the KubeCon community we kind of know what it is.
Yeah, even like, it's a much smaller conference, right? But I remember seeing stuff like this for DevConf, which is kind of the technical Red Hat conferences that we do, that are kind of very open source oriented. But even there, we saw eBPF stuff kind of landing. So I think I think you're right on. I think there's a lot going on with that tech, and being the kind of insider show, it'd be a good idea, if you're not already kind of tuned into what's going on in that community, it'd probably be a good idea to start paying attention to it, because it really does seem to be the wave of what we want to be doing, for lots of different kinds of functionality.
So-
Cilium is one exemplar, but not necessarily alone, or definitely not alone, I guess.
Well, since we have the container security expert here on the broadcast with us, I want to go straight into actually kind of the security questions, which is, okay, if we say project to the near future where we've kind of completed at least the current planned eBPF feature set. And people are using eBPF plus Kubernetes plus, container runtime, etc. How close is that to the level of protection we would expect out of a virtual machine platform in terms of isolation of processes?
So, I think all the time we're talking about containers, we have to be very aware that we're sharing a kernel. All the
Yes.
containers running on a given host have one kernel, and that kernel has visibility and access into everything, all of the processes running in all of those containers on that host. Now, this is where eBPF becomes really powerful, because if you run an eBPF program in the kernel, it has visibility and potentially the ability to change behavior for every single process on that machine. And that includes every single container in every single pod. So, there's a lot of power here. And, you do have to treat that power with respect. You have to treat eBPF programs the way you would treat anything else that you would run essentially as root. But we can use we can use eBPF to create stronger, let's say, security profiles. I don't really want to say security boundary, but we can lock down more efficiently what any given application can do. And this is something that I think people have been talking about for quite a long time. And the idea that if you have an application and it's only supposed to contact certain network endpoints and it's only supposed to read certain files, maybe it isn't ever supposed to contact a payment gateway. There are all sorts of things we can do with networking policy to limit what any given containerized application, any given pod can do in terms of network activity. But with eBPF, we can take that even further, because we've got this very, very granular visibility into what's happening. So we're going to be able to say not just, okay, this pod has, is trying to contact this particular IP address. We can say it's actually trying to contact this particular domain name, and the process that initiated this request was this given executable name. It was started at this time. Here's the whole process and tree of that connect request, for example. That's going to allow us to be very, very specific about what's permitted in our system. So, for example, how often do we really need to run curl in a production environment? Seems like it'd be
hopefully going to say right. Hopefully never.
Yeah. I was going to say when I'm doing things correctly.
So let's assume we're not SSHing into our pods and running curl. It would be pretty cool if we were able to write some some security profiles that say we don't expect you to run that curl executable. Or if we do, we only expect it to be run to access this particular endpoint from which this particular application, has to download some information. We can be very, very specific. That's the power and the promise of eBPF from a security point of view. The fun bit is going to be creating all the correct profiles and making it easy to get those profiles right.
Yeah, exactly. That's always it's always the challenge. I also like to bring up, I read a lot of spy novels, and in talking about security layers, right? So in the tech world, I think most people who even have a kind of glancing understanding of security recognize that having layers of security is usually the right answer, right? But that's also true if you're a spy and you're trying to break into someplace or whatever. And so I think it's also really interesting, right? Because it's adding another kind of opportunity for a layer of security. But to your point, right, it does require us to really think about the security profiles and not only making them work correctly, but then also making them easy to develop and all that kind of thing, right? I mean, I think the SE Linux adoption went way up as soon as they started to have nice tools that could tell you how to fix what's broken because your SE Linux profile is blocking something, right? But now you can get really good information about, why is it being blocked? Is it intentional? And here's an easy way to change it if that is something you do want to be able to do for whatever reason. Sometimes you do want to be able to call curl, for example. So I think we would like to move on to maybe talking about some CNCF stuff. However, in an attempt to turn this from a podcast into a Twitch stream, I think we're going to try to restart the stream. So please bear with us for a few minutes while we, ask Restream to restart. And I'm also going to throw this in the chat because of the delay on the audio. But does that make sense?
Yep, we are restarting everybody in an attempt to get video.
Exactly.
Okay.